This lesson is for Mrs. Cucci's College Now PreCalculus class. Today we are on lesson 6.1, Identities, Pythagorean, and Sum and Difference. So go ahead and get that opened up and we'll get started. Okay, so by the end of this lesson you will be able to state the Pythagorean identities, simplify and manipulate expressions containing trig equations, and use the sum and difference identities to find function values. Now, today you're going to be taking your own notes in your notebook, so please make sure that you have that out in front of you. I'm not giving you guided notes today. I'm going to have you guys write everything down. Okay, so what we're going to do is first we need to talk about what an identity is. Okay, an identity is an equation that's true for all possible values of the variable. So again, an identity can be defined as such. So an identity is an equation that is true for any value chosen for the variable. Okay, so we've got some basic identities that we're going to look at. Okay. Now, a lot of these basic identities we already know, but we're just going to do a quick reminder of them. So our first one, and these are our reciprocals. We know that sine of x is equal to 1 over cosecant of x. Cosine of x is equal to 1 over secant of x. And tangent of x is equal to 1 over cotangent of x. And vice versa, cosecant of x is equal to 1 over sine of x. Secant of x is equal to 1 over cosine of x. Oops. And cotangent of x is equal to 1 over tangent of x. Okay, we've got a few more. We can also have the identity sine of negative x is equal to negative sine of x. Cosine of negative x is equal to cosine of x. Tangent of negative x is equal to negative tangent of x. And just a reminder that we know tangent is sine over cosine, and cotangent is cosine over sine. So it will be your responsibility to make sure that you have these identities written down on a note card if you'd like to use them. I'm not giving them to you. That this is going to be your responsibility. Okay? Now, we do have one very important identity that we spoke about last year, and it was one that I told you guys you had to have memorized. That identity was called the Pythagorean identity. Okay, look at how we do that. Our Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Okay, so that is our Pythagorean identity. We also know that we can kind of create other identities by adjusting this Pythagorean identity. So one that we can do is if we take our Pythagorean identity and we divide it, say, by sine squared theta, this will give us an equivalent identity, but basically in another form. Okay? So what is this equivalent to? Okay, well, sine over sine we know is 1. Sine squared over sine squared. Cosine squared over sine squared is cotangent squared, and 1 over sine is cosecant squared. So this is another identity. Okay. Similarly, if we take sine squared theta plus cosine squared theta and divided everything here by cosine squared theta, we get another identity, or similar identity, Pythagorean identity. And we know sine over cosine is tangent squared theta plus 1 equals secant squared theta. So all three of these are Pythagorean identities. They're just in different forms. Okay, so those are your three Pythagorean identities. Now, keep in mind that this identity here can be written in alternate ways. You can solve for sine squared theta or cosine squared theta in order to get different setups, as can the rest of these, really. So it's just a matter of taking and adjusting them to get them in the formation that you would like. Okay, so let's look at what those might look like. We're going to start with our sine squared theta plus cosine squared theta. And what its equivalent forms are. Okay, so one equivalent form, let's say we wanted to solve for sine squared theta, we would simply subtract over that cosine squared theta, and this would be an equivalent form. Likewise, we can solve for that cosine squared theta to get another equivalent form. Okay. Let's look at the 1 plus cotangent squared theta equals cosecant squared theta. And again, these identities are going to be your responsibility. Okay? So what you can do here is you can solve for 1 minus cosecant squared theta minus cotangent squared theta. 1 equals. Or you can even solve for cotangent squared theta to get cosecant squared theta minus 1. Okay, so it's just different forms. One more. Tangent squared theta plus 1 equals secant squared theta. And we can solve for tangent squared theta by subtracting the 1. So tangent squared theta equals secant squared theta minus 1. And that's one that will actually pop up quite often. We can also solve for tangent squared theta to get an equivalent identity of secant squared theta minus 1. Oops, I just did the same one twice, didn't I? Sorry about that. My apologies. Let's try that again. Okay, let's solve for 1. 1 equals secant squared theta minus tangent squared theta. Sorry about that. Okay, so we've got a whole bunch of equivalent identities that we can use. So let's take our identities and start simplifying some trig expressions. Okay, so the first identity that I'm going to take a look at, or the first expression I'm going to take a look at, is we are going to multiply and simplify cosine x times tangent x minus secant x. Okay, so we're going to multiply and we're going to simplify. So I know that my multiplication step here is going to be distribution. So we're going to go ahead and distribute. So this is going to give us cosine x tangent x minus cosine x secant x. So now, since we've multiplied, my next step is to simplify. And the way I'm going to simplify is by replacing my identities with their equivalents. So tangent and secant is what pops out at me. So we're going to go ahead and we're going to replace tangent with sine over cosine. And we're going to replace secant with 1 over cosine. Okay? So what you should notice happen here is my cosines should cancel, or simplify to be 1 is a better way to say that. And I should be left with sine x minus 1. And that is multiplied and simplified. Okay? So there's no general procedure for simplifying trig expressions, but it is helpful to write everything in terms of sine and cosine, and then look for Pythagorean identities if they exist. Okay? So let's take a look at another example. This time we're going to factor. So this is example 2. We're going to factor and simplify. We've got sine squared x, cosine squared x, plus cosine to the 4th x. Okay, so it says factor. So we know when we're talking about factoring, we're looking first for a greatest common factor, if at all possible. Okay? If this is difficult for you to see, another way that you could possibly look at this would be to write it just with variables, so it's easier to see. So, for example, we could rewrite this as y squared x squared plus x to the 4th, where x would be cosine and y would be sine. Okay? If you need to do that, that's fine, but you do need to make sure that you write it back into its trig formation. So, if I'm looking at this, I need to think about what my GCF might be. Okay? And in this case, notice I have cosine in both. In one I have 2 cosines, in the other I have 4. So my greatest common factor is going to be cosine squared x. I'm going to be able to take that out or factor that out. When I factor that out, I get sine squared x, this gets pulled out, plus cosine squared x. Okay. Now, this should be popping out at you, sine squared x plus cosine squared x. This is our Pythagorean identity, and you should know that that is equal to 1. Okay. So, what we have here, when simplified, is cosine squared x. Okay? All right, so let's take a look at another example. Example 3. And we're going to simplify the trigonometric expression. We've got cotangent of negative theta over cosecant of negative theta. Okay, so the first thing that I'm thinking to myself when I look at this is I know what cotangent and cosecant are equivalent to, and I could replace those. So I think that I'm going to start by doing that. Okay? I know that cotangent is cosine over sine, and since it's negative theta, I have to make sure that I include that. And I also know that cosecant is 1 over sine. Okay, so now what I'm left with is I have that complex fraction. How we deal with complex fraction is to multiply by the reciprocal of that denominator. So we're going to go ahead and rewrite that as multiplication. And then what you can notice here is, again, I've got this simplification of sine of negative theta over sine of negative theta, which is going to reduce to be 1, or simplify to be 1. And what I'm left with is cosine of negative theta. And we saw that from our identities before, cosine of negative theta is equal to cosine of theta. Okay, so again, it's one of those identities because the cosine function is even. Okay, so that's why that works. All right, so let's look at another one. I'm going to do 2 sine squared t plus sine t minus 3 over 1 minus cosine squared t minus sine t. Okay, so it looks like to me in the numerator I'm going to have to try and factor that. It's a quadratic, and it looks like it may be factorable. So that's going to be my first step. I know I'm going to have 2 sine t and sine t. And I know it's going to have to be 3 and 1. I'm just not sure in what order quite yet. Okay? So I have to try something. Let's try 3 and 1. When I FOIL this out, I get 2 sine squared theta, 2 sine theta, 3 sine theta. I guess I should be saying t. So 2 sine t, 3 sine t. Is there a way for me to get 1 sine t from 2 sine t, 3 sine t? Of course. If this is a positive 3 sine t and this is a negative 1 sine t, I'm sorry, negative 2 sine t, this will give me a positive sine t. So that's what I'm looking to do. Okay. In the denominator, however, I don't have, I have mixed trig functions, which I don't really care for at the moment. Okay. So what I need to do is figure out a way to adjust that. All right. Now, if I look at just this piece here, what you should notice is 1 minus cosine squared t is an identity. Okay, it's that Pythagorean identity, it's just written in another form. What I can do is I can replace that Pythagorean identity with its equivalent. So that's going to be sine squared t. And then I need to keep my minus sine t. Okay, so now in the denominator I notice again that I do have a GCF. So I can go ahead and I can take that out. And that's going to be sine t. I'll be left with sine t minus 1. Again, we've got a simplification that it can occur. And I can be left with 2 sine t plus 3 over sine of t. Okay. Another way to kind of write this is we can split it up. 2 sine t over sine t plus 3 over sine t. These would simplify, and I'd be left with 2. And 3 over sine t, we know this is like 3 times 1 over sine t, right? We've seen that before. We know 1 over sine is cosecant, so I could rewrite this as 3 cosecant t. Okay, so both of these are correct. There's just different ways to write the solutions. Okay? All right, so that's all we're going to do for today. We will continue on with this lesson tomorrow, and we'll continue with multiplying, simplifying, reducing these identities. All right, thank you guys.